Okay, so the next talk will be by Scholz, and he will talk about the reality versus expectations of in-place CPU and memory resizing. So the stage is yours.
Thanks, and welcome everyone to my talk. My name is Jakub. I work as an engineer at Cloudera, and I'm also a CNCF ambassador, and I am a co-founder and one of the maintainers of the Strimzi project. And Strimzi is all about running Apache Kafka on Kubernetes, and Kafka is one of the bigger workloads. Well, these days nothing is bigger than AI, but Kafka is still quite big, and it's quite hard to size the Kafka clusters. So that's why in Strimzi, we are always looking for things such as auto-scaling and things like that to kind of make the Kafka clusters a bit more efficient. And 2 years or a year and a half ago, I did a talk about horizontal auto-scaling in Salt Lake City at KubeCon, but Kafka scales very nicely horizontally, but it isn't very elastic because it has all the stateful data. So when you are scaling it horizontally, you have to move the data and so on. So it's not something you can use to kind of scale up and down every 5 minutes. So that's why the vertical auto-scaling has some appeal for us as well. And that's why the in-place pod resizing feature seemed really interesting. And that's why I started looking into it. And in this talk, I will first kind of give you some introduction of how it works. And then in the second half of the talk, I will talk a bit more about the practical experiences, the various gotchas, limitations, and things to be aware of. So just to get started, the in-place pod resizing was introduced in Kubernetes 1.27. But what's probably most important, it moved to stable and GA in 1.35. So it's now enabled by default. You need it supported by your container engine as well, but I think it's supported in all the recent versions of Cryo and Containerd and so on. So that should not be a problem. And what it does, it allows you to change the memory and CPU resources allocated to your pods and to your containers without restarting them. And that's great because less restart means less disruption. It makes vertical auto-scaling much easier. And it also allows you to kind of think about some special use cases, such as having some startup CPU spikes handling, where you have a bit more CPU at the start, and then you lower it down, for example. So how does it work? When I talk about it with various people, a few times I notice that they somehow think that with the in-place pod resizing, they just edit the deployment or the stateful set or whatever they use, and it will kind of magically resize the containers without the restart. Well, that's not really how it works. If you just edit the deployment or the stateful set and change the resources there, you will get the same rollout as you have been getting in the past, so nothing changed there. Instead, if you want to use the in-place pod resizing, you have to edit the pod, and you have to use this special resize sub-resource to kind of resize the pod dynamically. And of course, resizing the pod doesn't have any impact on the other pods managed by the same deployment. It doesn't in any way change the deployment or the stateful set. So if you want to do that as well, you would need to do that separately. So let's have a quick look at a short demo. So I have here my deployment already running. It has a single pod. It's just a simple. So let's first try to do kubectl edit deployment. And let's edit the deployment. So it's just a normal deployment. And let's find the resources. And let's change the resources to 600 milli-CPUs from 500 milli-CPUs. Let's apply the changes. And as you can see here on the side, exactly what you would have normally expected happens. The new pod is rolled out with the new resources, and the old pod is deleted. So instead, as I said, we have to actually edit the pod. And first, let's check the status section, because in the pod status section, you have actually the container statuses section, and that shows the resources configured for this container. And you can see that the 600 milli CPUs we just used in the deployment and 2 gigs of memory. And then, of course, in the spec section, there is the desired resources configuration. So let's give it a try and change it to 800 milli CPUs. And now let's apply the changes. But here at the bottom, if you check, I'm now not just doing something like kubectl apply or something, but I'm invoking the resize sub-resource, which will make sure that I just resize this pod. So I run it. And if you noticed on the side, kind of the pod blinked few times as it was updated. So let's close the editor and let's just get the pod YAML. If I manage to stop making typos. And if we check the status section, now here we can see it has the 800 milli CPUs, which I just configured there. So the status suggests that we have resized the pod successfully without any restarts. But just to make sure, let's do kubectl exec into the pod. And let's check this C group information about the CPU we are using there. And you get these 2 strange numbers, and you actually have to divide them to get the actual CPU you have. So in our case, it's 80,000 and 100,000. So if we divide that, we get 0.8, which is exactly the 800 milli CPUs which we configured the container with. So you can see that kind of the resizing didn't just show it in the pod status, but it actually also showed in the actual container in the C groups, which you can see there. So now the interesting question to talk about as well is what happens when there's not enough resources, because I really just bumped the CPU resources by a little bit, just by 200 milli CPUs. That's not much. But there are these kind of special states which might happen if you do some bigger changes. One of them is, it's called infeasible resizing. And that's basically if you would try to resize the pod and the containers inside to the amount of resources which are not available in the node. So in that case, it would kind of move to this infeasible state where kind of Kubernetes knows that, yeah, this will never resize because the node simply doesn't have the capacity. And then there's other state, which is, let's say, slightly better, which is deferred resizing, which means that in theory, one day this resizing might be possible because the desired size, it's not bigger than the capacity of the worker node. But right now, this resizing, it's not possible, maybe because other applications are running there and they are kind of taking the space. And that's why the resizing is deferred. And maybe one day, once the pod move away, the resizing would actually happen, because then suddenly there would be free capacity for it. So let's have a look at another quick demo. So let's exit from the pod where we were running, and let's edit the pod again. And this time, let's try to increase the CPU properly, and let's go from 800 milli CPUs to 800 CPUs, just a little bump. So I will use again the resize sub-resource. You can see on the side, it still updated the pod. But when I actually get the YAML of the pod, you will see the resizing didn't happen. The container status still says it has only 800 milli CPUs. And when I scroll up and go to the conditions, I will see here that, yeah, the pod resizing is pending. And the reason for that is that the resizing is infeasible. And it's basically because, yeah, I requested 800 CPUs and my node has 10 CPUs. So, well, that will never happen, right? So let's try to do the other case. as well. And to make the math easy, let's go for the 10 CPUs, which is the node capacity. Let's resize it again. And let's check what happened here. And still 800 milli-CPUs, still nothing happened. And when I go to the conditions, now it actually changed. It's still pod resize pending, but this time it's deferred. The reason for that is that I requested 10 CPUs. 10 CPUs is actually the capacity, so in theory it might fit, but there's actually 750 milli-CPUs in use, and so it cannot be resized right now. Now, just in this simple demo, the reality is that the 750 milli-CPUs, they are used by the networking, monitoring, and so on, so they will probably never go away. But if these were some other applications, then maybe they would restart, reschedule to a different node, and the resizing would actually happen. So another thing to consider is that so far I have been changing only the CPU, right? And there's a reason for that. CPU is a compressible resource. I'm not sure if everyone knows what compressible resource means, but it basically means that the applications handle it pretty well when you change the amount of CPU they have. So if you have some process which is running with some CPU capacity, then that kind of defines how many CPU cycles does it get, how much time on the CPU. And if you give it a little bit more, then it just gets more time. It finishes the job faster. If you give it a little bit less, then it will be a bit slower. It will get less time. It will take more time to complete. But in general, it works, at least unless you make it really, really, really low, that you cause some CPU starvation. But with memory, it's a bit more complicated, right? Because if you have an application which is using 2 gigs of memory to store some data in the memory, you can't just come and say, okay, I'm now taking away 1 gig of memory. You wouldn't really expect such application to survive when you just remove half of the memory it's using. You can still do the resizing of the memory requests and limits as well, but it's a bit more complicated. Kubernetes kind of gives you this basic protection that it doesn't allow you to lower the memory below what the container is actually using at the time when you try to do resizing. But with the memory, it's a bit more complicated than that, and I will get back to it a bit later. But now just to show you how Kubernetes kind of handles it. So let's edit the same pod again. And let's go back to the 800 milli-CPUs here. And let's try to lower the memory to 1 gigabyte only. Let's resize the pod. And let's check how the resize worked. So no resizing so far, still using 2 gigs of memory. Actually, it still says that the resize is in progress. So let's try to just update it and get the new status. And here we see that it says pod resizing progress failed. It's in error state. And the reason for that is because I tried to set the memory limit to this amazing number, which should be the 1 gigabyte. And it's using slightly more. So the desired size is below the actual usage. So that's why it didn't resize the container. So that's a bit more about the memory, which is a bit more tricky. Obviously, what I was showing in these simple demos was that I was resizing the pods using kubectl edit pod kind of manually, right? And in your production environment, you probably wouldn't want to be running with kubectl edit pods and using some resize sub-resources manually. It's probably not feasible if you have more than few pods. It's probably not very secure. It's easy to make some typos and so on. So in reality, you would probably use some tools to do resizing for you. The most obvious one is the Kubernetes vertical pod autoscaler, which does have support for in-place pod resizing. And Another option might be OpenCruise, which is, I think, incubating CNCF project, which also can help with things such as resizing, and it provides its own controllers and so on. And actually, we in Strimzi, we added support for the resizing as well for our Strimzi workloads. So you would usually use kind of tools like these to actually do the resizing and not run around with kubectl and kind of patch the resources on a pod by pod basis. But when you start using the tools like this, it's sometimes good to be able to kind of set some policies and establish some rules how the different applications handle the resizing. And that's why the container configurations also have now something called resize policies, where you can define directly in the container configuration how should the container behave when you try to resize the CPU or the memory. And basically you can say whether the container does support it without restart or whether restart is always needed. And you can define it separately for memory and CPU, because basically for the reasons I explained, that scaling the CPU, that's pretty simple and works pretty well. Scaling the memory, it's much harder without the restarts. So I, for that, just will apply slightly modified version of the deployment. So we will see new pod created, and now we can try to edit the pod again. And what we can see here, so here are the resizing policies, where I basically tell Kubernetes that for CPU resizing, no restart is required. But for memory resizing, the container should restart. So let's now try to change the memory. Let's this time try to go to 3 gigs of memory, so we will increase it. So in theory, there should not be problems with the pod not having enough memory. But because we specified that a restart should happen, then here on the side, you can see that the pod was updated, but here you can see now it wasn't just in place, but there was a container restart. So one of the difference between editing the deployment and doing the resizing just with the enforcing restart through the policy is that you won't have a new rollout of the pod as you would have if you change the deployment, but instead the container would just restart inside the pod, which is something to keep in mind, because it can also impact the things such as availability of your data, of your application services, and so on. Right, so let's continue a bit more. There are some more rules and limitations. So the first one is that you can today resize only CPU and memory. You cannot resize any other resources. Obviously, it's still a relatively new feature, so this might change in the future, but right now this is the state. You can't also change the quality of service classes. So if you have these guaranteed best effort, burstable quality of service classes, which are basically based on how you configure the resources, whether your requests and limits are the same or whether the limits are higher. And you can't kind of change it. So if you have the request and limit at the same value, you can't just increase the limit, because that would change it to the burstable class. Similarly, the resizing applies only to regular containers and sidecar containers. It doesn't apply to ephemeral containers, and it doesn't apply to init containers, which is quite obvious because in most cases they are not running once the pod is running. You also cannot remove the request or limit. So if you have your pod configured only with requests, you can change the request, but you can't just add limit in place without properly rolling the pod. I just briefly want to touch on how we did pod resizing in Strimzi. Strimzi is using its own pod management. We are using our own custom resources to manage the pod, so we are not using things such as deployments or stateful sets. And unfortunately, right now that means that the vertical pod autoscaler doesn't really work with the Strimzi pod. So to kind of allow us and our users to play with this and benefit with this, we actually build support for the in-place pod resizing directly in Strimzi. And the way it works is that users can, if they opt in for this feature, because it's not enabled by default, but if they opt in and enable it, they can basically just edit the custom resource and change the resources there, and Strimzi will automatically apply the changes to the pods and resize them in place if possible. Let's skip the demo of that for the sake of time, and let's talk a bit more about the practical side of things and what I learned when trying to use it. Again, mostly with Strimzi and Kafka, but I think a lot of the learnings apply to other applications as well. So is it as simple as it looked in the demos? Well, unsurprisingly, it's a bit more complicated, right? The CPU resizing, that really works pretty fine almost everywhere. That's pretty straightforward, but the memory depends quite heavily on your application, how your application is designed, what's your application's architecture, but also what programming languages are you using, what runtime environments are you using, what frameworks, and so on. So you need to know these things, and Kafka is actually written in Java, which is probably one of the more challenging languages for this, but yeah, again, it's not completely different from other languages, so a lot of the stuff applies everywhere. So first thing, let's briefly touch on Java and the CPU. There's actually no major issue in the CPU resizing with Java, and actually one of the really interesting thing for a lot of Java applications is kind of the possibility to handle some startup CPU spikes, because a lot of the Java applications kind of need more CPU to kind of warm up when they are starting to kind of load all the classes and process them and so on. So the idea that you kind of, for example, start your application with 2 CPUs, and then after it gets up and running, you kind of decrease the CPU to 500 milli-CPUs or something like that. It's pretty interesting. I know a lot of applications which would struggle to start with less than 1 CPU, but once started, they can easily run with 100 milli-CPUs without any problems. So that's an interesting feature. The memory, as I already explained, it's pretty complicated. So the main memory which Java applications are usually using is the Java heap memory. And it's basically configured through a minimal size of the Java heap and the maximal size of the Java heap, and it's configured when the application is starting. So either by the user directly, by some operator like Strimzi, or if nobody else specifies it, then Java will kind of check what's the available memory and set the limits on its own. So that's set at startup, and there's no way how to change it dynamically in some way. There are some plans and proposals how to improve this in Java, but right now that's the situation. And going back a bit to the Kubernetes protections, which they have for the memory resizing, like imagine you start the Java application on the beginning and you say your maximum Java heap size is 5 gigabytes of memory. But right now the application just started, it's not doing anything, and it's using only 1 gigabyte of memory. So actually Kubernetes would let you resize the memory of the container from the original 5 gigabytes to 1.5 gigabytes, for example. But Java would not be aware of it, and a few minutes later it decides to do something, allocate some memory, and it still lives with this 5 gigabyte limit. So you would suddenly run out of memory, and that's kind of Kubernetes give you some protection, but they don't really know about insides of the container and what runs there. Scaling Kafka on its own, it's even a bit more complicated than Java itself, because Kafka brokers are often pretty big pods with a lot of memory. So having Kafka brokers with 64 gigs of RAM, it's not really exceptional, but the way you typically run Kafka is that you will not have the Java heap use the whole memory. You would, for example, have the pod with 64 gigs of memory request. You would configure Java to use only 8 or 16 gigs of that memory, and you will kind of just reserve the memory for the disk page cache. The disk page cache, it's basically everything Kafka writes to the disk is the recent messages are stored in this cache. And when then Kafka needs to kind of read these messages and pass them to the consumers, then it doesn't have to kind of read from the disk. It just reads them from the cache if they are recent enough. And that gives us quite a lot of performance. But it also means that a lot of the memory is just the disk page cache. And the good news is that the disk page cache doesn't seem to have problem when you dynamically change the memory. So if I reserve more memory by increasing the request, the page cache will start using that memory. If I decrease it, then the memory will be gone, but the page cache can handle it. The bad thing is that the page cache in general uses any possible available memory, so it doesn't give you any kind of feedback loop. You don't know whether the memory is really the bottleneck. You don't know whether increasing the memory helps or whether decreasing the memory actually causes some performance issues. Kafka has one other workload. It's called Kafka Connect. And that's actually a bit more traditional Java workload, which doesn't write that much to this, doesn't rely on the page cache. And that's actually a bit easier to scale from the CPU perspective. The heap issues are still there. But yeah, it's one of the typical workloads where kind of the startup CPU stuff can be really useful. There are some infrastructure issues as well, which are really general and have not much to do specifically with Kafka or Java. But with Kafka or with many other big workloads, you often tend to use dedicated nodes, right? But if you have a dedicated node just for one application, there's actually not much value in scaling up or scaling down because, well, nothing else will use the capacity you free. So you won't really save any money. You won't really save any energy. You won't be any greener and so on. But you can take it even a step further because when we are running our Kubernetes clusters, one of the things we get from Kubernetes is this bin packing feature, right? It helps us to keep the utilization of our worker nodes high, and that's what we really want. We don't want to have thousands of worker nodes, each with 5% utilization. We want them to be really tightly packed with applications and having high utilization because that means that, yeah, we are using what we are paying for. But that also means that there's less space for the applications to scale. So if you have this tightly packed node and then you try to increase the CPU or increase the memory of your pod, then it can very easily happen that the resizing will always be just deferred because there's no space on this node because there are other pods running, right? So that's something what can be a bit challenging as well, because it's a bit hard to predict whether your resizing request would end up in this deferred state or whether the resizing would actually happen. So we are going towards the end, so let's do a bit of conclusion. So I think the in-place resizing is a useful tool, but what's important to keep in mind is that it doesn't come for free, right? You need to kind of do some stuff to make sure you get some value out of it. And the first thing is that you have to know and respect your application. So if you are a pure operation person, just running someone else's application, and you have the idea, okay, I will start using this in-place pod resizing tomorrow, it's not that great because, yeah, maybe the applications can't handle it, right? So you need to first talk with application developers and see whether the applications can handle it or not. But maybe if you really want to use this, you should also plan a bit your architecture, your infrastructure, because maybe having large shared worker nodes would work better for you than having smaller dedicated nodes, because as I said, when you have dedicated node, there's not much point in resizing things. Maybe you want to also kind of mix some long-running pods and some short-running pods on the same worker node. So if you have some pods being these long-running Kafka brokers or databases, and then you mix it with some jobs which do just some processing for 1 minute, that kind of gives you the churn in the cluster so that you have always space to do the resizing. And finally, one thing to kind of a bit decide is whether you can rely on the in-place pod resizing or not, because in a way, you are trading guaranteed scale for guaranteed lack of disruptions, right? If you use the in-place resizing, You know that there won't be unnecessary disruptions to your applications, but you actually don't know for sure whether the application will scale or whether it will be deferred. So if you really need the performance from your application, maybe it's better to just kind of change the deployment or scale horizontally or use the vertical auto scaling, but without the in-place pod resizing, because then you know the pods will roll, they will be scheduled on a node which has capacity, and they will have the capacity then. They won't be sitting there as a deferred resizing. And that's pretty much it. So in the Strimzi community, we are always interested to work with users and improve the things, how Kafka clusters autoscale. So if you are a Strimzi user and are interested in this, feel free to get in touch with us on Slack, and we can try to improve these things and continue this journey. And otherwise, thanks for your attention. And I think we should have a few minutes for questions. So the first question, you mentioned memory request downsizing is forbidden. Is it possible to downsize the limits? It's not forbidden to downsize the memory requests or limits, but you can't make it smaller than the memory your application is currently using. So if your application is using 1 gig of memory, then you can't go below that, but you can, for example, change the memory request or limit from 5 gigs to 2 gigs, and Kubernetes would not necessarily mind. Whether the application can handle it or not, that's a different story. So I think that hopefully answers that. The next question is, what if pod process is partly in swap? Can memory be changed online? I actually didn't include it in the slide, and I would need to check the docs to be 100% sure, but I think if you are using swap, then you cannot use the in-place resizing at all. Can the restart policy be changed in the running pod? To be honest, that's a good question, and I never tried it, and I'm afraid I don't have the answer. I have it running there, so maybe we can try to change it later after the talk. When CPU count changes during runtime, how JVM and GC handles that regarding the number of threads? I think that a bit depends on how exactly is the JVM configured. I think in most configurations, there's now no direct relation to the number of cores it sees at startup and the number of threads it actually uses. So I don't think there's any major blocker right now. I think Golang had something similar around the number of CPU cores, but to be honest, I don't know how much it matters there these days or whether that's now irrelevant. The next question is, will it work for Java to set heap size with percentage and not XMX? So XMX, that's kind of the maximal limit for the heap size. You can also specify it as a percentage of the available memory, but it still applies that the percentage, it's kind of calculated on the beginning at the startup, and once you are running, it will not change. So if you change it from 100 gigs memory to from 10 gigs of memory to 100 gigs of memory, and you had the percentage set to 50%, it won't dynamically change from 5 gigs to 50 gigs. So it will still be the initial thing. Does the app get any signal when C group limits change, or is the app expected to poll these manually? I don't think there is any signal, at least I'm not aware of one. And in the most applications I used it with, you actually don't need to really do much to understand that the C group limits change, because in Java with the memory, you can't do much even programmatically. And with CPU, it just gets used. How does Strimzi in-place resize with other vertical autoscalers? So when Kafka pod is resized by some other application, it would not be immediately reverted by Strimzi, most of the other resources would be automatically reverted, but not for pods, because we have there this kind of special mechanism where we track some special annotations which contain the hash of the revision of the pod configuration. And if you change it through some other means, either directly or through some other tooling, then we should not see it and we should not revert it. So that should not be a problem. Do you know if there's a plans to support pod priorities and preemption in relation to deferred resizing? I think there is some support for it, but I will be completely honest with you, I didn't dig into it in a detail. Yeah, so integration with the priority classes, yeah, that's pretty much the same. I think there is some built-in support how these things are scheduled and how other things might be evicted, but I didn't kind of dive deep into that, so I can't comment much on it. What I can say is the different tools can also kind of combine these things. So what we, for example, have in Strimzi is you have to opt into the in-place resizing, but you can also say what Strimzi should do when the resizing is deferred. So in Strimzi, you can, for example, say that if the resizing was deferred, then Strimzi should actually roll the pod the old school traditional way and not just wait. So that's one of the options how to handle these things. And looks like that's all the questions. Thanks, everyone.